Right, in each of these you need to take the trouble to do your oxidation numbers, so let's go. Which substance is reduced? Well, we've got at least chlorine on its own, so it's 0. Iodine's on its own, so it's 0. Potassium's in group 1, so it's +1. Iodine's in group 7, -1. Potassium +1, -1. So we can now look at oxidation and reduction. Remember, if my oxidation number goes up, I am oxidized. If my oxidation number goes down, I have reduced, because that shows the gaining and losing of electrons. So 0 goes over here to -1, so that was obviously reduced, and -1 on the iodine goes to 0, so that was obviously oxidized. It's going to be a bit squashed, I think. Anyway, carry on. What substance is reduced in this reaction? So we've got chlorine being reduced. Which substance is the reducing agent in this reaction? And so it's exactly the same reaction, so I'm just going to look at it. The reducing agent got oxidized. So it is this species over here that got oxidized, which is I-. Which substance is oxidized in this reaction? And once again, we're going to go through the process. So it's 0, 0, +1, -1, +1, -1, +1, -1. So if I'm going to now show myself, the reduced is that, and my oxidized is that. And the question is, what is oxidized? So it's the iodide ion again. What substance is the oxidizing agent? That is the substance that got reduced. So it is going to be the bromine. Which substance is reduced? And once again, I need to do my oxidation numbers. So it's going to be +2. The sulfate ion as a whole is -2. I'm not sure whether I'm going to need to break that up. In the meantime, I'm not going to, because I'm going to keep my life simple. The two substances on their own are going to be 0, +2, and -2. So now what do? I link on, and I have got going from +2 to 0 is reduced. Going from 0 to +2 is oxidized. So which substance is reduced? It is the Cu2+ ion that is reduced, not the copper sulfate as a whole. The sulfate is just a spectator ion. Very boring. Which substance is the oxidizing agent for the reverse reaction? So it's the same thing. The oxidizing agent for the reverse reaction, everything just flips around for the reverse reaction. So if we consider the reverse reaction, it is the substance that got reduced in the reverse reaction. So it's going to be this substance over here that got reduced. Why? Because it was this that got oxidized in the forward, so it gets reduced in the reverse, and therefore it is the oxidizing agent in the reverse reaction. Which substance is the reducing agent in the reverse reaction? So I'm just going to consider, well, let's see, we're going to have to do this twice, but it's fine. So let's look. We've got +3 because it's in group 3. The whole sulfate ion is -2. If you add it all up, it's not difficult to work out that this is 3 times 2, which is -6. 2 times 3 is +6. It all comes out like neutral. Here's 0. Here is +2 for the magnesium, which is in group 2, and -2 for the sulfate ion, and 0 for aluminium when it's all on its own. Next thing is to decide what got oxidized. So the substance that and what got reduced. So aluminium goes from +3 to 0, so that has been reduced, and oxidized was magnesium up to +2, so that was your oxidation. It's not great on 2 lines like that. Anyway, we're looking at the reverse reaction. I'm going to go to number 8 first. Which substance is oxidized in this reaction? It was your magnesium. Now looking at the reverse reaction, what was the reducing agent? So it was what got oxidized in the reverse reaction. Whatever got oxidized in the reverse reaction was reduced in the forward reaction, so it's going to be the aluminium. Well, the aluminium relationship, but it's the reverse reaction, so what's what's acting as a reducing agent? Aluminium. Okay. In the following reaction, which substance is the reducing agent? So again, 0, -1, +3, +2, and we're going to go from the reducing agent must be the substance that got oxidized. So that's your oxidation, so it's the Fe2 plus ion. Which of the following statements concerning the reaction below is correct? So we again have to go through the effort of putting in oxidation states. So it's plus 4 minus 2, 0, 0, plus 2 minus 2, and we're going to say plus 4 goes to 0, which means that was reduced. 0 goes to plus 2, that was oxidized. So both magnesium and sulfur dioxide are oxidized. That's a load of rubbish. One's oxidized, one's reduced. Sulfur is oxidized. This is a one-way arrow in that direction. So sulfur is nothing. We can only decide to use the reactants, so that's rubbish. Sulfur dioxide is reduced. Yay, that looks like a good answer. And magnesium gains electrons. No. Magnesium loses electrons because it is oxidized. Consider the following. So the one is just the same reaction that we've got up there. So if you don't mind, I'm not going to just do it all over again because it's tedious. And we're going to go plus 4 minus 2, plus 1 minus 2, 0 plus 1 minus 2. And taking a look, we have got minus 2 going to 0 on the sulfur over here. So that is oxidized. And we know that magnesium went to magnesium 2 plus, so that was oxidized. So what are my reducing agents? The two things that got oxidized. Sorry, that's an error over there. The answer is D. Which of the following reactions is not a redox reaction? So this is quite important because how we're going to work these things out, we actually have to have some basic knowledge of chemistry. So we're going to say zinc and hydrochloric acid. We know that a metal plus an acid gives me the salt plus hydrogen. We can quite clearly see that those must be 0 and that must be minus 1 and plus 2. So that is a redox reaction. Magnesium burns in chlorine. Let's think it through, even if we haven't done it. Magnesium and chlorine has a pretty good chance of forming something called magnesium chloride. I think that's reasonable to assume. 0, 0 because they own their own. Plus 2 and minus 1, there's been some reduction and oxidation going on. Zinc spoon is left in copper sulfate. CuSO4. It becomes pitted, so it obviously does go through a reaction. It's reasonable to think that some ion exchange took place here. And we know that zinc is more reactive than copper, so it's going to steal its partner. And what has happened? We have got 0 going to plus 2 and plus 2 going to 0. So that is a redox reaction. Let's hope the other one is right. Concentrated hydrochloric acid is added to saturated solution of sodium chloride. Well, that is simply the common ion effect. There's nothing, in fact, there isn't even a chemical reaction there. It only shifts the equilibrium of the dissolution process. So everything stays the same, and I'm just going to write that out. HCl, Na, and Cl. There isn't even a chemical reaction. That's plus 1, that's minus 1, that's minus 1, that's plus 1, and they stay in those oxidation states throughout. So D is your correct answer. The conversion of the dichromate to the chromium 3 plus ion, let's see what happens here. We have got we've got minus, let's first just get a bit of space here. We've got minus 2, and it's times 7, so it's minus 14. I need that all to add up to minus 2, so it's going to be plus 12, which means that this is plus 6. The chromium goes from plus 6 to plus 3. That means that it was reduced. So it's going to be one of these reductions, and we know that reduction is the gaining of electrons. What is the oxidation number of the atom underlined? And it didn't get underlined, which is very sad, but it is the chromium ion. And the oxidation number for that is plus 6. And finally, an oxidizing agent undergoes reduction. Yep, that's the truth. An oxidizing agent is therefore going to gain electrons, not lose electrons, and its oxidation number, it's going to be reduced, is going to go down.